The Sustainable Forages webinar and podcast is a series of informative and engaging conversations about sustainable forage production and management practices. Each episode features experts and innovators in the field discussing a range of topics, including soil health, grazing management, and the latest research on forage crops. Whether you're a farmer, rancher, or just interested in sustainable agriculture, this series is a valuable resource for anyone looking to learn more about the importance of forages in a sustainable food system.
Hello, everybody. We don't want to keep everybody waiting too long, so we're going to get started now. I'm Grant Lastuca, and I work as a director on the Alberta Forage Industry Network. We're so fortunate to have our chair, Dr. Surya Acharya, and also Ed Shaw as vice chair. And the Alberta Forage Industry Network is a body that looks to go ahead and communicate in the industry for Alberta. In so doing, our goal is to speak with one voice for forages in the province. And the board and committee members are committed to fostering two-way communication, championing research, extension, and influencing policy and practice. And this tonight, we're so fortunate to have Dr. Erick Santos, and this is part of the get to know the researcher and get to know the research. It's an important one. I worked for 10 years at the Lacombe Research Center with a bunch of researchers, and my admiration for them grew all the time. Very simply, they do some wonderful work, and it's a real opportunity for two-way communication for the sake of somebody like Dr. Santos, who I got to meet and know a little bit through time, and teaches the Forages course at the university. And he started as an assistant professor in forage science at the University of Alberta in 2023. He had acquired his background in master's and BSc from the Federal Rural University of Pernambuco. I hope I have that right, in 2014. And in 2017, and then in 2021, I got his PhD in agronomy at the University of Florida with a focus on forage and grazing. Dr. Santos has been a postdoctoral fellow at the University of Alberta for 1.5 years before becoming a faculty member. And during his PhD, he received several awards and recognitions. The Gerald O. Mott Merit, I can't even say the word, I better skip it almost. Graduate Students Award in Crop Science, Fred Hall Award of Excellence, International Student Outstanding Achievement. Dr. Santos's research topics include grass legume mixtures, crop livestock systems, cover crops, nutrient cycling, strategies to extend the grazing season, and assessment of ecosystem services provided by grasslands. Dr. Santos serves as an associate editor of the Grass and Forage Science and Crop Science journals and is the chair-elect for Forages and Grasslands section of the Crop Science Society of America. To date, Erick has published or co-authored 1 book chapter, 53 research papers, 84 abstracts, and 42 extension reports or prints in the popular press. And I was looking on LinkedIn at the time when I realized he had received 2 awards from the Crop Science of America for his excellence in research papers. So a great upcoming young scientist for us to get to know. And largely what we're looking for here is bringing producers to the researchers and vice versa for communication. So this edition of Sustainable Forage webinar podcast series is recorded, so it's going to be available for everyone to see afterwards and watch. The question period I don't believe will be, but the talk will. And Dr. Santos is going to talk about the impacts of grazing intensities and crop livestock systems on soil, plant, and water dynamics. So though this research was carried out elsewhere, the principles are always what we're looking for to get into our hands so we can create our own understanding. And I'm excited to pass this over to Dr. Erick Santos to start his presentation. Go ahead if you can, please.
Yes, I was just unmuting myself. I thank you so much for the introduction, Grant. Yes, it was a nice introduction. Thank you so much. I'm at the University of Alberta now, as Grant said, but the research that I'm gonna present, it was like a research that we did perform over the course of 4 years, and I still did that when I was in the US, okay? But of course, there are some messages, some important messages that we can translate and see how we can apply some of those concepts to the agricultural systems that we do have in Alberta. And I'm glad that I was looking to the audience here, and I was fortunate enough to meet some of you in person already. So I'm glad that you could come here. And okay, so this was mostly the research that I did in my PhD, was one of my main projects in my PhD. And I still collaborate with the folks that are running this setup there, and the trials is still running, although we have some differences nowadays from the time that was performing my research. But the trials is still running, and we have like some more interesting results coming out. So we're gonna talk about several studies today. First of all, whenever Grant did extend the invitation for me to come here and present this research to you guys, it was mostly to talk about the SWOT responses of Bahia grass managed across different grazing intensities. This was one of the papers that was awarded with like outstanding paper in the Crop Science Society of America. But this is just a small piece of the whole project that we have. And I guess the systems approach of the project is what it is interesting to bring to you instead of just one particular responses of a warm season grass, okay? So in this overall project, we do talk about, so we have cover crops, we have crops there, and then we are analyzing the soil responses as well. And in some of the systems, we can plant cover crops during the cool season, and then warm season grasses during the warm season. And everything it's supported actually because the Florida Department of Agriculture and Consumer Services, they were sponsoring this research project in order for us to find ways to mitigate the nitrate leaching that's coming from agricultural systems, because I'm going to cover that. It's one of the major problems that we have in Alberta. Okay, in Alberta, sorry, in Florida. Okay, so since this was conducted in Florida, I want to give you a little bit of background so you know what the agriculture looks like in Florida. So we have peanuts, cotton, field corn, and sweet corn as the main crops in there. And usually they are planted into a rotation. And sometimes, for example, for field corn, you can plant field corn. And after harvesting the field corn, we can still plant sweet corn in the same year, in the same land. But usually those crops, they are rotated and they account for the most income coming from crops in the state, okay? So if you drive in Florida during the summer, you're gonna find lots of row crops, okay? One of the particularities in Florida is that we can grow warm season crops and cool season crops as well, okay? So we can do, we have some windows where we cannot grow anything, but other than that, we can grow like warm season crops and cool season crops. But most of the cash crops that we have, they are warm season crops, okay? Like peanut and cotton. So if you drive in Florida during summer, you're gonna see lots of fields like that, okay, with the warm season, with the cash crop growing, and maybe some irrigation. It's very common to have irrigation there. But then if you drive in the same field during the cool season, you're just gonna find like a field like that, a fallow field, which can lead to soil erosion and nutrient leaching. This picture here, it was taken in front of the research station that I used to work. And if you take a picture nowadays, you can see lots of holes here. And there's a lot of water that gets accumulated. And this is because they're losing the topsoil. And just look again here to this figure. Soil there is very sandy, okay? And it's more prone, even more prone to erosion, okay? So erosion is being one of the major concerns. But another concern is that over there in the region that I was working, the county that I was working, we have the Florida Blue Springs, which is basically a first magnitude springs. And there are lots of algae boom occurring in that Blue Springs. And it is estimated that half of the nitrates in that Blue Springs comes from agriculture. If we see just in this graph here that has the total nitrate, the total nitrogen and nitrate trends in the Florida Blue Springs, we can see that from 1958 until 2011 here, there's an increase in the total nitrates and nitrogen in that Blue Springs, okay? So by knowing that, we need to come up with some strategies to decrease that abundance of nitrogen that's being leached to the water, okay? So a common rotation, very common rotation in Florida is to rotate peanuts with cotton, 2 years of cotton and then peanuts, okay? Peanuts are legumes, they fix nitrogen, so they put some nitrogen to the soil, and later that nitrogen, after the roots decompose, after the residue decompose, you know, some of that nitrogen can still be utilized by cotton, so it's a nice rotation. But with time, that rotation ends up with stagnant yields and soil degradation and pest and disease, okay? And soil degradation because, well, we're gonna do like some till or maybe even no till, but the reality is that the soil is not gonna be covered throughout the year, okay? Dr. David Wright, he did start a big project with a sod-based rotation system. And his idea was to add 2 years of Bahia grass, which is warm season grass. And it could be another grass, could be another warm season grass. Some people in the region do that with Bermuda grass, okay? So he introduced the sod-based rotation system. And by the way, just want to acknowledge that he did that research for about 20 years, and he did pass away about 2 years ago, but his legacy is still there, still running. So he did introduce 2 years of grass, warm season grass into the rotation. And after that, we plant peanuts and then cotton and come back to grass, okay? And some of the results show that there is an improvement in soil quality, increase in yield. You know, it can break some of the pest cycles, reduce risks because, for example, I did perform a trial there, like with cotton, and we had a hurricane that year, so all the production was lost. But then if you have a diversified system, it can become more resilient and increase profitability at the end, okay? So we have these two systems. And then whenever I started doing my PhD, I wanted to do something more because those are all warm season crops or warm season pasture. And I said, well, we have a gap, okay? So during the cool season, we can still plant cover crops. And if you are planting these cover crops, you can also graze those cover crops and see how that's gonna affect the crop responses. Just a definition here. So we have like several definitions for cover crops. I like this one here because it's very simple, okay? So cover crops, any crop grown to provide soil cover regardless of whether it is later incorporated or not. If we incorporate, we can call it green manure, and we plant just as catch crop to prevent nutrient losses, okay? So there are some benefits that are specific for the issues that I was looking for. For example, decreased nitrate leaching, okay, from 6 to 94%. So lots of studies in there, depending on the cover crops, depending on the species that you have, the range it's gonna be more towards the up portion or the upper portion or the lower portion. Improve soil properties, reduction erosion, compaction, increase organic carbon, and increase nutrient cycling. And specifically for cotton yields and decreasing weeds, you know, cotton seed and leaf yield, they increase a little bit whenever we add cover crops. This was a meta-analysis. I don't remember how many studies they did evaluate, but it was over 100 studies, I believe. And then other components, it's we
And
have
I
the
can't
leader,
get
right?
it any louder.
Sorry. I'm sorry. Okay, I'll just keep away. Okay, so and then we also have the leader that after we graze, it's left in the soil, right? And the
And it's
quantity
not
and
coming through the
quality.
headphones, so I'll just listen here.
Sorry.
Go ahead, Eric. It's okay. Go ahead.
Okay. Okay. So anyway, so the quantity and quality of leader will depend on the plant species, nitrogen fertilization during that time, and stocking rates that we are utilizing. And then basically this graph here is showing a field that we had an initial or pre-intensive cultivation level. Okay, let's say we have the relative soil organic carbon concentration, and we keep doing like tillage. Here is the current level. Okay, so this is not to scale. This graph is not to scale. But then there are some technologies that we can implement in order to increase the soil carbon level. For example, no-till alone. Okay, so if you do no-till alone, you can perhaps like keep same level until from that point. But then if you have like no-till and start adding cover crops, we start increasing the rate of accumulation of soil carbon at a higher pace, okay? And then no-till, other technologies like cover crops plus nitrogen fertilization, so we can, or other fertilizations, we can still keep it increasing that soil carbon. Instead of plowing and removing the residue that we have, those things they are gonna decrease the soil carbon, okay? So here, we do have another graph showing the product of maximum bulk density with no cover crops. Okay, so we have a more hard soil, a greater bulk density whenever we don't have any cover crops. But then using soybean or sun hemp. By the way, I'm gonna be doing some sun hemp studies this summer. So by adding some cover crops, we can decrease that bulk density, which is gonna create a better environment for the roots to grow, for example. And then we also have the soil organic carbon. Of no cover crops, well, we have the least soil organic carbon in the system, but then whenever we are adding soybean or sun hemp, and by the way, both of them are legumes, we can increase that soil organic carbon, okay? So in Florida, I was in North Florida, so it's a completely different scenario from South Florida. In South Florida, we can grow basically just warm season grass throughout the year. Of course, whenever it's winter time, whenever we get close to like November, December, January, those February, those colder months, like some of the species there, some of the grazing that occurs is mostly on stockpiled forage. But in North Florida, we can plant some of the cool season legumes, what we call it, the cool season legumes there. So some examples are the crimson clover, hairy veg, rye, and black oats. Okay, so those are some cool season crops that we can plant and use as cover crops. In Florida, pretty much like Alberta, Florida is it's a cow state. Okay, so we have in Alberta, I know that we have like basically most of the cattle in Canada. Okay, so Florida it's not like that, but it is a cow state, so the calf is the crop there. So they have about 1 billion beef cows. Okay, and those beef cows, they are grazing mostly bahia grass during summer. And why graze cover crops? Okay, so we have those beef cows, but we also have the calves that can gain some more weight before getting shipped to other feedlots. And we have heifers that we can do heifer development programs, okay? So bahia grass, so this is the average daily gain of animals grazing bahia grass during summer, okay? So 0.34 kilograms per day. So not impressive, okay? So, but if you have dry cows, well, that could work. But then whenever we go to the cool season, we can plant those the temperate grasses. And usually whenever the animals are grazing those temperate grasses, for example, here we have mixes of ryegrass, oats, ryegrass, and triticale and ryegrass. They're gaining like 2 or 3 times more compared to what they were gaining whenever they were grazing bahia grass, okay? So usually the animal performance whenever they're grazing those types of forages, it's better. So and what would be the benefits of grazing the cover crops? The first one here, improve land utilization, because instead of just leaving a fallow field during the winter time, well, we could have animals grazing. Increase the profit, okay? Improve nutrient cycling, and increase resilience to market fluctuations and weather phenomena. As I told you, in the case of the hurricane or a drought condition would be another one, right? Some challenges. So here in Alberta, I was fortunate to meet like many mixed farmers. So that's not very common in Florida. So some of them will be just working with cattle, and some of them will be just working with crops. So there's the producer skill set and the infrastructure, because if you're just basically just growing crops, you don't need um, to put a fence and everything, right? And then if you're just working with animals, you don't need to buy the metal that you need for growing the crops. And again, some people, and that's a very important point, some people are very worried about soil compaction, okay? Because the soil compaction could potentially decrease the crop productivity in the next season. But then, so this is related to how you graze your pasture, right? So what is grazing? Okay, so we have like two grazing scenarios here, but then in this one we can see that there's a lot of biomass. We have like an undergrazing scenario. In this one, well, the animals don't have too much forage to sustain their growth, let's say like that, or their performance. So there's a wide range of grazing, and of course we want to stay in the optimal zone. We don't want to be like undergrazing or overgrazing, right? Because at some point this system here is going to collapse. You're going to start losing per animal and per area. And here, of course, it's clear that the gain per area is not being the greatest. Okay, so we want to reach that optimal zone. Okay, and it was a little bit of introduction just to give you the background of what we were doing. And I'm going to discuss about five experiments that we did. And some of these methods, they apply for each one of them, for every single one of them. So first of all, it's a little complicated, the number of treatments that we had, but we had in total 9 treatments. First one, and I'm gonna divide those 9 treatments in 3 sets of 3 treatments, okay? So the first one, it's what we call conventional. And then we have treatments that they differ in winter and summer, okay? So in the conventional, for example, treatment 1 here, so during the winter, we have no cover crops, and then we plant cotton during the summer. And then we have the cover crops here plus 34 kilograms of nitrogen during winter, and then cotton again during the summer. Here, cover crops plus nitrogen and crop during summer. In the second system, we still have the same cover crops receiving 90 kilograms of nitrogen, but then now we are adding animals, okay? So, and those animals, they're gonna be grazing those cover crops at different intensities, like overgrazing, moderate grazing, undergrazing. Summer, still we plant the crop. And then we have the sod-based rotation, which we have same cover crops during winter, but then during the summer, instead of the crop now, we have Bahia grass, which is a C4 grass, a tropical grass. And now we put the animals to graze same intensity, okay? And we did that like for 3 years. And in the 4th year, we planted peanuts in every single plot, okay? So for the grazing management, whenever I say like overgrazing, moderate grazing, and undergrazing, I was utilizing some methods to keep after the animals graze. We were doing like some mob stocking. The animals would graze every 14 days to keep the residue at 500 kilograms, 1500 kilograms, or 2500 kilograms of dry matter per hectare after they leave, okay? And this was done during the cool season for the grazing treatments and during the warm season for the grazing treatment. So the target was 515 and 2500, okay? So the real was a little different, but this was the target. So we would keep animals there grazing all the time so we could keep the difference between treatments. So this is how the trial looks like during the winter, and this is how the trial looks like during the summer. We did perform the study in Mariana. It was here, very close to Alabama and Georgia. So the precipitation there is, well, it's impressive, but the evapotranspiration is always, it's also very high. So here is the treatment during winter. We have, so basically every 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one block, and then we have another block here. We have another block here. So I have 3 blocks in general, so 3 reps. And here you can see some of the plots that were not grazed, some of the plots that we just had, it was fallow. So this was treatment 1. This plot received 90 kilograms of nitrogen, similar to this one. And anyways, we do have differences between treatments. And here we have cattle grazing the warm season grass. And beside that, we have cotton growing, okay, in some of the other plots. So for the cotton lint yield and the grazing on the cover crops, we did not have all the treatments in this trial because some of them we did not plant the cotton. We had just the warm season grass being grazed. Okay. So again, so these were the intensities that we applied, and this data is for 3 years of data. Okay, we had five grazing cycles from February to April, and this was like the residue that was left in each plot that was grazed. Okay, so we did evaluate pre and post grazing herbage mass, herbage accumulation. So how fast was the herbage accumulating? How fast was the forage growing in each of these plots? And for nutritive value, we did look into the in vitro digestible organic matter and crude protein. Okay, we also looked to the standing residue of the cover crop, weed proportion, soil cover, and the cotton lint yield at the end. So this was just a video showing like the beginning of the cotton. Okay, so I have the link there, and now we have the seeds here. So this is just to show you how it would like across grazing cycles, the difference between treatments. This was like the pre-grazing herbage mass, okay, and then we would put the animals to graze, and after they leave, the plots would be like that. So that's the post-grazing herbage mass. The green line is the overgrazing, the blue line is the moderate grazing, and the yellow line is the undergrazing. So we can see that those differences between treatments were maintained throughout the season, but the target and the actual was a little bit different, but pretty close. Okay, so this was the target, 500, 1500, 2500. This was the real, okay? But at the end, whenever we did the statistical analysis, everything was different. So what happened to the herbage accumulation? First of all, we had the undergrazing, actually the treatment that was not being grazed to the ground was accumulating herbage at a greater pace compared to the other ones. But we also had a difference between the early season and late season. And this was caused because the plants, they did reach maturity at the end of the season, and after they start growing, well, they just mature, they would not grow back anymore, right? So for the crude protein and in vitro digestible organic matter, we have a treatment by year by evaluation effect here. But overall, we can see that, of course, like the plants that were less mature, they had a greater crude protein at the end, and usually a better digestibility of the organic matter as well, okay? Because they were younger compared to the other ones, compared to the undergrazing, for example. But the trend was the same. Usually nutritive value for the overgrazing was greater, moderate in the middle, and the treatment with the least nutritive value was the undergrazing, okay? So this is just, I just want to show you, like, so for the treatments that actually had a cover crop during winter, so this was the residue that was left whenever the trial was stopped, so we could plant the crops. we had some differences here. So these are the treatments that were not grazed at all, like not grazed plus 34 kilograms, not grazed plus 90 kilograms. So of course they did have more biomass at the end. But for the treatments that were grazed, it was important for us to have these differences here between treatments. So we know that treatments were imposed successfully, okay? And I do have another trial evaluating the decomposition of this residue, which I'm not gonna present here, but I'll let you know what the work is, okay? So for weed presence, have the weeds more in the overgrazing treatment, okay? And the no grazing treatment plus nitrogen, there was not so much weeds in those. And whenever we look to the soil cover, no cover crops, okay? So, and of course, if you don't plant anything, the weeds will take over. That's why we still have some soil cover in there. But the overgrazing resulted in very low soil cover. Whereas the undergrazing, moderate grazing had so much, as much soil cover as the plots that were not grazed. For the cotton lint yield, what happened is that, well, our yield was not impressive at the end, regardless of the treatment. So we did not have difference between treatments. And in the first year, it was particularly low because we did have a hurricane in that year. So this was the year of the hurricane. It was not looking great. But overall, the average cotton yield for the state was 880 kilograms per hectare, and ours was a little lower. But nowadays, some of the fertility in the soil was corrected, and we did fertilize every single year, but it just takes time for the fertilizers to take place. And the yields in those plots for the cotton, it's much greater nowadays, okay? But in these particular years, we did not have any difference between treatment. Okay, so this was the trial that actually Grant saw online. This was evaluating only what's happening whenever we are grazing that warm season grass than in summer. Okay, so here we have barrier grass with different grazing intensities. And for that trial, we basically have only 3 treatments. Okay, so the overgrazing, moderate grazing, and undergrazing on the C4 grass. And we did evaluate similar responses as pre-graze and post-graze herbage mass, herbage accumulation, and crude protein. We also did evaluate roots, okay, because if we are pushing too hard, so if we are defoliating very frequently and very close, what's happening to the below ground biomass? So I'm always curious to know what's happening with the below ground biomass as well. So we did collect some cores, wash the roots, and this plant has lots of rhizomes as well, so you can see the rhizome here. So we did evaluate the roots and rhizomes. And we did everything on organic matter basis to correct for soil contamination, okay? So that's just the stats. I don't wanna, spend much time on the stats, but similar trend here, we can see that usually, so that's basically just showing that the treatments were imposed, okay? So we can see clearly the difference between grazing intensities here among the overgrazing, moderate grazing, and undergrazing. And again, the target and the actual, they are a bit different, but they were all different, like statistically. So they were like A, B, and C. They were all different from one another. Okay, so the treatments, they were imposed successfully. For the herbage accumulation, we did not, so this graph is only showing a difference between year and month. Okay, so we did have some year variation. Usually, I do believe that 2019 was a drier year, but we still had like some good accumulations happening in July and August. But yes, we just basically had a year difference, which is normal. No year is gonna be similar to the other. But for crude protein, we did have some differences, and the differences, they were usually because overgrazing had better crude protein or higher crude protein compared to the undergrazed treatment, okay? So overgrazing, undergrazing, and moderate grazing usually in the middle. And of course, like in some of the evaluations, those differences, they do not occur, okay? But usually, Bahia grass, nutritive value is not as good compared to cool season crops, okay, cool season forages. So here we have the soil cover. We did some contrasts, and you can see like the more overgrazing that you have, like the least soil cover, okay? For the root rise on biomass, we can actually see that the overgrazing is depleting the below ground biomass, okay? So the below ground biomass in this case, it's decreasing as we increase the grazing intensity, okay? So from undergrazing to overgrazing, we are losing some of the below ground biomass. And for the weed frequency, we did divide that into spontaneous grasses and other weeds, okay? Overall, we had, putting those together, across treatments, we had like 36% of weeds, but this is pulled across treatments, dividing that. So what we have here, so spontaneous grasses, okay? They were appearing more in the overgrazing compared to the undergrazing. And for non-grass weeds, like the other weeds, they just had a year effect. So we were not applying any herbicide in those treatments. So the annual weeds, they started like coming up like some years from the first to the third year. So some of the soil responses here, going very fast. We did evaluate deep soil responses and also soil responses just in the top 15 centimeters of the soil. For that, we did evaluate in every single trial in all the 9 treatments. We collected samples, baseline samples that were collected at the beginning of the trial in 2017, and then again in 2019, and we did collect again in 2021, but it's not in this presentation. So it's gonna be in a paper that will be published like I hope by the end of the year. And we collect again in 2021, but this is just the early data. Okay, so what happens in 2 years? And I bet we know that not a lot's gonna happen in just 2 years of trial, but we have some results here to show. Okay, we did some macronutrients. We did potash, phosphorus, and ammonia and pH, organic matter, book density, and from 0 to 15 centimeters, we also did carbon nitrogen analysis in the aggregate. So we utilized this root tab to separate the soil in different fractions. Okay, so here's the soil after we separate in different fractions from 200 to 50 to 2000 micrometers, 150 to 250, 53 to 150, and what passed through the 53 micrometer sieve, it's what we have like here in the pen. So basically those are the different sizes of aggregates that we evaluated. And we did run carbon nitrogen by dry combustion. So these are the soil cores that we collected. So we divided that into 4 layers from 0 to 15, 15 to 30. This is not to scale, of course, 30 to 60 and 60 to 90 centimeters. We had 3 cores in each plot. 2 of them we did a composite, and the other one we utilized it just for book density and do calculations afterwards. And here's just the stats. I'm not gonna go through the stats. I just wanna show here that we did do some contrasts. Okay, so cover includes everything that had a cover crop. Okay, no cover, basically it was just one treatment that did not have the cover crop. So grazing, it's a group that included all the treatments that would have grazing. No grazing, a group that includes the treatments that had no grazing, so all the no cover crop plus nitrogen at 2 levels. Okay, so this was no grazing. We have the ICL, which is the intercrop livestock, which includes the treatments that were grazed during winter and then crop during summer. And the sod-based rotation is the treatment that we had grazing the cool season crops during winter and then they were grazed again in the summer on the C4 grass, okay, on the tropical grass. Okay, so some of the results, okay, this is it's a big table. Just want to highlight some of the results. We had a difference here whenever we did a contrast for cover crops and no cover, okay? And you can see that planting cover crops decreased the book density compared to no cover. So that's the first good result from the soil. And this was just like two years after implementing the treatments, okay? For P, we had a difference here between grazing and no grazing and sod-based rotation and ICL, okay? So the sod-based rotation had the least phosphorus concentration in the soil. And I do believe this was caused because some of the phosphorus was retained in the rhizomes of the warm season grass, okay? So doesn't mean that, so the phosphorus was just in another location. Was still like in the soil, plant, and animal cycle there, but it was just immobilized in the rhizomes of the Bahia grass, okay? And pH, okay, so the pH for the sod-based rotation was a little higher compared to the no grazing and intercrop livestock only. Organic matter as well, okay, so for the sod-based rotation, we had an increase of 1.5 grams per kilogram. It's not a lot, but in Florida, the soils there, they are very poor in organic matter. The average of the state, it's 1%, okay? So whenever I came here, I found some soils with 10% of organic matter. We could basically utilize those soils to fertilize the soils from Florida. And then we have an ammonia nitrogen concentration here in the sod-based rotation as well. So there was nothing happening in the aggregate fractions. Okay, so it was just like as we decrease the size of the particles, we were increasing the concentration. Okay, and then there was an opposite effect for the stalks. Okay, just because we had more of that particle size compared to this one. For some of the nitrogen responses and carbon as well, again, no difference between treatment. And here's just showing that we had greater concentration in the top layer. Okay, so this was expected, except for these ones, whenever we have like the greater amount of stock for nitrogen in the layers of 30 to 60 centimeters and 60 to 90 centimeters. But again, so these layers, they were longer compared to the ones on the top. Okay, but usually fertility at the top and the carbon at the top, they were higher compared to the other layers in the soil. Okay, so I did mention a little bit about the nitrogen leaching, and why did I mention that? So this whole project was basically performed because we wanted to find ways to decrease the amount of nitrates that go to the blue spring, right? So we had these drain gauges in every single plot. So we had like, it's a very high density of drain gauges. We have 27 there. Okay, so we installed that. This was in the first year of the trial, like prior initiation of the grazing. And of course, there's a time for those lysinomeres to settle down, but we did install those lysinomeres in every single plot, and we did collect samples to evaluate what was the nitrate concentration in water, in leachate, okay? So they were installed, so that's the depth, 1.5 meters. We would collect those samples bi-weekly and analyze for ammonia and nitrate, nitrogen, and ammonia, nitrogen. And for the statistical analysis, we did one for the summer from mid-May to October, and one for the winter from November to May. That's how we call it, summer and winter. They're not necessarily summer and winter, we know that. And we did that for every single trial. Okay, so first of all, no difference in 2018 here at the beginning. We have like some crazy variations, but it takes time for those like lysimeters to settle down. So we did not expect much to happen here regardless. 2018 summer, we have like some variations happening there, but they're not showing anything in particular. But then once we go to 2019 and especially 2020, we can see, well, this blue bar here, it's the only treatment that we do not have cover crops. And we can see that the cumulative nitrate leaching in that particular treatment is greater compared to any other, regardless of cover crops and crops, or cover crops and then Bahia grass, or cover crops or the perennial grass and some. Okay, so basically, so this was the response here. In 2019, again, we had a dry year. Okay, so there was just not a lot of water, but also the evapotranspiration was higher, so not much nitrate was being leached that time of the year. Okay, and then 2019 here again, and in this graph, okay, I want you to pay attention mostly in these 3 little bars, because all of them are the treatments that we have the perennial grass during summer. Okay, and we can see that planting the perennial grass during summer is being beneficial for decreasing the amount of nitrates that's being leached. And then, so this graph here is very complicated to understand. Okay, so so to put it in simple terms, I did the same contrasts. Okay, so in here we can just compare cover and no cover, and we can see that having cover will decrease the nitrate leaching. Okay, grazing and no grazing, so the treatments that will graze compared to the other ones, well, it's actually been beneficial. Compare both crop livestock systems, the one that we have, the warm season grass, it's been better in terms of reducing nitrate leaching compared to the integrated crop livestock alone. And then, so here was the biggest difference between sod-based rotation and no grazing. Okay. So here's just a graph showing the nitrate concentration. This is the total, okay, and this is just the concentration. The treatment with perennial grass had a lower concentration compared to no grazing, lower concentration compared to the other intercrop livestock system, and then cover usually a lower concentration compared to the treatment that we did not have any cover crop at all. Okay, so covering that, but I did tell you that in the last year, and I believe this is going to be the last portion of the presentation, the last data of the presentation, in the last year of the trial, in the 4th year of the trial, we did terminate the crops. We had to terminate the perennial grass, terminate the tropical grass, the Bahia grass, and we did that. And then we planted peanuts in everything. This is after digging the peanuts, so the peanuts could dry and being harvested. Okay, so this was like in the 4th year of the trial. I guess this is a video just showing like whenever we were doing those not those traces, those swaths there, like with the peanuts. Okay, I think this one is it's a graph as well. That's Bill Conrad. He's a producer there, and he did help us doing this work during that time. So okay, so the planting of the peanuts was in May, and then it was harvested again in September. And last year it was the end of the 2nd rotation, so peanut was harvested again. Okay, so we had cotton, the peanut, and then for these treatments here in green, we had perennial grass, and peanut. Okay, so this was the year that we sampled the peanut after some years into the rotation. So what happened to the peanut yield? Well, not a big difference, but this was significant. Okay, so everything that I'm showing you here was significant. So the grazing actually did increase the peanut production a little bit. Okay, so the integrated crop livestock was better whenever we compared to no grazing as well. And the sod-based rotation system was better, even better, was the best one whenever we compare to the no grazing system. So the home message here is that well, integrating crops and livestock, it's helping in the peanut production, and at least it's not decreasing the cotton yield. Okay, so it's a win-win scenario. Some of the concluding remarks. So the grazing cover crops during the eco season may increase the land use efficiency in North Florida, at least without affecting the cotton productivity. Controlling grazing intensity is important to assure soil cover and decrease with frequency. Compared to conventional crop systems, sod-based rotation may enhance the soil organic matter and soil mineral nitrogen. Adding cover crops can reduce cumulative nitrate leaching in crop livestock systems. And moreover, warm season perennial forages can further enhance this benefit. And the last one is that the peanut yields tend to increase when adding grazing animals and perennial forages into the rotation. Okay, so I did publish like many studies from that site already. I still have at least another 2. So like the grazing part was highlighted in the Journal of the Environmental Quality, and these 2 are in crop science. Both of them were awarded as well. And this one was published in the Grazing Forest Science. And of course I have other papers still coming up. I know it's been some time that I finished my PhD, but I just built so much data from that trial, and it takes some time to publish everything. And then I would like to acknowledge like the North Florida Research and Education Center. Whenever I was in my master's and PhD that I performed at that I did perform at the North Florida Research and Education Center, I was always in the research station. I was never on campus. I spent like about just 6 months on campus, but I spent much time in the research center. And also I would like to thank the Florida Department of Agriculture and Consumer Services because they were the sponsors for this trial. Okay, I hope I did not extend myself too much, but I'm gonna be happy to take any questions if you have them, and yeah, and if I have the time. Yes, thank you.
Thank you, Eric. And if anybody has any questions, if they wish to raise their hand or put them in the chat, then we can ask them of Eric. And I know one of Eric's goals is to do research that matters for ranchers. So from that standpoint, and knowing him and his wife Gleese a little bit, I think we've got some tremendous young scientists here with some real opportunities for us to get questions answered in our industry. So if you've got any questions, please, if you could put them in the chat or ask them verbally by putting your hand up. One thing I saw with your work is you're combining a lot of things, and the fact that some of us are looking at our soil bulk densities and everything. So a lower bulk density is better. Is that what you're saying with that one slide?
Yes, it's better, right? It's better for the roots to grow, right? If you have like a more loose soil, like, right?
So more porosity, more living, breathing soil presence. Okay.
Yes, yeah, more space, more air. You can, yeah, have some more of that organic matter there as well. So having a good amount of organic matter, it's gonna decrease the soil bulk density, right? So if you have a lower bulk density, it might, maybe it's because you have like more organic matter in the system. And then if you remove the organic matter, you're just left with like the sand, silt, and clay there, and can be very heavy.
I also noticed with the peanuts and the yield. Now, peanuts, as you said, are a legume. So it wasn't the nitrogen you put in the system probably that did make an impact on the peanuts. What do you think it was on the peanut yield?
On the peanut yield. So here, of course, well, the peanuts adding nitrogen, but here I'm showing like difference between those treatments, and all of them had peanuts, but still some of them were better compared to the others. So let's say that the peanuts were fixing nitrogen at the same rate. So basically they received the same amount of nitrogen. What I think is happening here is that, well, in the systems that we have more cover throughout the year, means that we are also adding more plant material that's decomposing, and it's going to be part of the organic matter. So that organic matter is making the nutrients more available for the plants later on. And because of that, we can have some greater peanut yields, right? So if you remember, and I know that I did speed up a lot because I was afraid I was gonna not be able to finish the presentation for you guys in a good time, and I know this one is long, but if you do remember, so this treatment, the sod-based rotation, this group at least, the ones that we had the warm season grasses during the summer, so this one had a better response in terms of soil organic matter. It was the one that was increasing the soil organic matter at the end. And I believe this peanut response here was caused due to the increase in organic matter that we had in that system. And this is so I particularly like that these results here, because this is just like 3 years after the implementation of the system of the rotation. So that's the 4th year, right? So the peanut was in the 4th year. So this is 3 years after having the perennial grass, and we already saw some good results. So it's very exciting.
Okay, and in the chat, we've got a couple of questions for you, Eric. From Naveen up at the Mackenzie Applied Research Association at Fort Vermilion. He'd like to know if you've tried sun hemp in Alberta yet. Naveen says, I think you mentioned you'd been planning to, and do you know of any varieties of sun hemp that can produce seed in Alberta?
Okay, so I did not try sun hemp in Alberta yet. I did work with sun hemp back in Florida. And then, but for this year, I'm planning, I have a master's student that just started, and one of her trials is gonna be about planting sun hemp and some warm season grasses, association of sun hemp and warm season grasses. I did do some sun hemp study before, but a completely different scenario, right? So that was in Florida. But well, I think maybe during the warm season here, we actually have some good temperatures, and I believe that the sun hemp can grow. Okay, so I can show the results that I'm gonna find in the next coming years. Okay, so after this growing season, but it's something that I'm gonna try this year. It's planting that sun hemp and see if we can just bring up another tropical legume to use in Alberta. I think that would be neat.
Do you have more than one variety?
Oh, is that I do. I'm planting at least two. One is crescent sun, and the other one it's blue something. I forgot like the name of the second variety, but I'm testing two varieties. At this moment, I'm testing two.
And you've got your email at the bottom, so Naveen can contact you to
Mhm.
find out the full variety name.
Yeah.
Now, Naveen also wanted to know about black oats here.
Black oats is something else that I'm trying this year. I'm gonna bring 10 different cultivars and plant them. I'm just gonna plant in Edmond first. I'm gonna do a pilot trial. I wanna see what's gonna work, what's not gonna work, and pick up some like the best candidates. So what happens with the black oats? We did a lot of breeding of black oats in Florida, in the station that I was working with, and we ended up with these 10 cultivars that were very promising. Black oats is very big in the south portion of Brazil. Okay, similar condition as North Florida, and we use that like in integrated systems. But then about 2 years ago, one of my lab mates, okay, so this guy here, Dave De Jaramillo, he was one of my lab mates. He's working for the USDA now in Wisconsin, and he did plant the same 10 cultivars in Wisconsin, and he had some promising results. Okay, and I decided, well, I want to bring black oats a little bit more to the north and see if it's gonna do well here. I'm not aware if someone tried that in Alberta before, but I'm planning on trying that this summer. Yeah, some planting 10 different cultivars of black oats.
Black oats benefit, or what is it used for?
It's just for grazing. Yeah, it would be an annual temperate grass. So it's Avena strigosa, scientific name for black oats. And usually we rotate that with soybean in Brazil. Like we graze black oats and then plant soybean another year. But it's in Argentina too, they have black oats. Yeah, it's not wild oats. I want to be very clear. I'm not bringing another wild oats to Alberta. It's not what I want to do.
Okay, we've got a few questions. So I'm going to take one more, and then I'll take Dr. Surya's got his hand up. But I'll first, why was Baha'i grass used as a perennial grass in a monoculture? Is it harvested for sale?
Okay, so Bahia grass, they plant Bahia grass in over it's the major. It's the major forage grass in Florida. Okay, so they have a say in Florida that we have. They have two types of pastures in Florida: the ones that are Bahia grass and the ones that will be Bahia grass. Okay, so
Oh,
Bahia grass dominates everything. So it's basically the to go forage for grazing, right? Because it's very persistent to graze, very, very persistent to graze because of just the amount of fruits and rhizomes that it has. It's very tolerant to grazing. And yes, it's mostly grown in monocultures because it's very competitive. Although we do have a trial with rhizoma peanut, okay? So this is a forage, rhizomatous forage. It's not the peanuts that we grow for crops. They have rhizomes and everything. So rhizoma peanut, we can grow in association with Bahia grass. Okay, so it's kind of the only the only legume that we can grow basically with Bahia grass and be successful. Okay, so we have a trial that's running for 10 years and it's a mix of Bahia grass and rhizoma peanut. And the results of that trial, they are very interesting. Um, some people do try Bahia grass with some annual legumes, okay? But if it's a good year, they germinate, well, we have good results. If it doesn't germinate, you just lost some money putting the seeds out there. And the legume that they usually would do that, it's Echinnomene. So yes, but it's very common in Florida to have monocultures in the pastures. It could be just Bahia grass, of course. They have like several different varieties, or it could be just Bermuda grass. And yes, they grow in monoculture. If there's too much forest, they harvest for hay and they feed the animals during the cool season. Okay, so not every single producer will plant cool season grasses, right? Just because you need the land as well. But you can actually plant the cool season crops on top of the Bahia grass, like in a no-till management, and it will grow. Okay. So, but yes, usually the pastures are there. They are monocultures or adding trying to add one legume or another, but it's never like two different grasses, okay? Because those warm season forages, they are very competitive, very competitive.
okay. I'll take the second question Alexis Jones has. Were the cover crop mixes chosen to meet the nutritional requirements of the cattle?
Uh, so for those cover crop mixes so we had like rye and oats that were the cover crop mixes. We did choose that because rye is the to-go cover crops basically in the state because just the seed is cheap. Okay, so it's what producers were doing. It's planting rye and oats because so we could try to maximize the grazing season by mixing two different grasses and oats and rye. So since they are the cool season crops, they can grow together much better than growing like any other crop with Bahia grass. So we chose those specifically rye because, well, rye was a to-go one, and oats in order to improve the nutritive value as well. And we actually, in that trial that we have Rhizoma peanut and Bahia grass during summer, we have a mix of rye and oats during winter, okay? And we knew like that the animal performance during that time was good, so we tried to combine some of the trials that we had, but it usually that combination usually results in a very good nutritive value for the animals. Okay, and then if you go like in one of my first slides, I did show some of the animal performance grazing those mixtures. Of course, it was a mix of rye and ryegrass, but rye and oats was pretty similar.
Because what I think Alexis was, she says here, I understand that this is better than the current cropping systems, but it still seems limited in terms of building soil communities and producing livestock that uh, are doing well, less input intervention like medication, etc. So that was part of what she was wondering about, I guess, the biodiversity beyond two grasses.
Yes, it was two grasses. It was mimicking like some of the, because it was more close to the reality. Is and if I tell you, so what producers in the region will do if they plant cover crops, because many of them don't plant, they would plant rye and put like 30 pounds of nitrogen. So that's the to-go management for cover crops. So we wanted to something that was closer to the reality. But I told you this trial is still running, but now we have different treatments. Instead of the grazing intensities, we have different combinations of grasses and legumes, okay? So now we are in another phase. We are adding red clover, white clover, crimson clover. So now the setup is different. It's more on the biodiversity side. Yeah.
Okay.
So the only grass approach for the cover crop was abandoned already, okay?
Okay. One of the comments made by Ron Curry was, and I guess he's right, peanut yields, there really wasn't significant statistical differences. They were a little different, but not statistically significant.
No, they were significant for, so the contrasts were significant. Yes, they were significant, like the contrasts were significant. So those are single degrees of freedom contrasts, okay? If you compare like the average of all the treatments, just because you have lots of noise, just 1 year of data, many treatments, it was not different. But then like last year, the data, it was significant again, because those, in order to have like a more clear data, it takes time and some more evaluation. And this is a type of data that we can only collect every 4 years. Okay, so it's gonna take time until we can decrease the standard error.
Okay, I'll bounce over to Dr. Surya Acharya, and then we'll come back to a couple more questions in the chat from Kim Nielsen and Panette Robinson. So go ahead, Surya, please.
Thanks, Eric, for giving us a nice presentation, and you are our lead speaker for this seminar series for AFIN. So I think I thank you for agreeing to do this. One question for you. I think you used mostly grasses for your as your cover crop, but what happens if you have a multiple species combination as cover crop? Do you think it would be any different?
Oh, yes, I do believe it would be different, especially if you are adding a legume to fix nitrogen, right? So then in my time, we were more looking into the differences in grazing intensities, but now we have legumes as well in that trial, and even here I did not talk anything about what I'm doing in Alberta, but some of my trials, they are looking into different number of species and functional groups, and what's going to be the benefit of that intra rotation, like have brassicas and legumes and grasses. So I do believe that, especially the soil responses. Something else that I want to bring up, I was just talking to 2 days ago to one of my colleagues, and he did collect some soil in that trial to look into soil microorganisms, okay? I'm not a soil microbiologist, but what I can say is that the treatment that we had, the light intensity, was resulting more soil microorganisms, okay? So the microbial biomass was greater in the treatment that we had, like the light intensity as well. So yes, and I do believe those responses they would be better if you had mixed species, yeah. Especially adding legumes would be beneficial.
Okay,
that
so
is
that
the trend nowadays here in Western Canada. I think most people are using multi-species cover crops. So that's what I thought. Probably you should be able to give us some advice on that.
Yes, and I'm gonna keep on doing research with cover crops and with multiple species as well, with those annual forages and those things, and I hope to get good results in soil. Of course, I always like to look to the whole system, right? As you saw, so I was looking to every single detail, water, plant, and anyways, even atmosphere. But yes,
Thank you.
thank you.
Well, I can see that that helps with Alexis's question, and the challenge I know that you've got here, and before I get to the next question, is you put in a lot of components to look at in the ecosystem, and the complexity is hugely complex, so it's hard to get all these answers. So you
Mhm.
almost have to take it a step at a time.
Oh yeah.
Kim Nielsen had a question. Just thinking of an easy way to monitor soil health improvements. Would there be a correlation between lowered soil bulk density and improved fungal dominance in the soil biome, as well as increased soil carbon from a healthier soil biome?
Yes, I cannot assure anything on the fungal part, but usually the soil bulk density is one of the metrics that we use for soil health. It's in the physical component of the soil health, and the soil carbon as well. It's another component in the soil health that we utilize. Usually, we have the Soil Health Institute. They came up with like at least three measures that we can use as a rule of thumb to determine soil health. One of them is the carbon mineralization potential. And the other two, so there's one with carbon respiration as well. And the third one, I did forgot that at the moment, but yes, there are some key indicators of soil health, but I cannot tell you what I think on the relationship between the soil bulk density and the fungal community, because it starts going to an area that I do not know. Sorry. Yeah.
Okay, thank you, Eric. Um, Panette Robinson, any idea how these results would translate to a much shorter season that we have in Alberta? And have you only done studies using cattle or other livestock as well?
So yes, I did. So to the first question first, okay. So one of my goals with those warm season crops and cover crops is to identify some of the best mixes to in the future add that into a rotation system, right? Because I'm not just planting those blends because I want to. I want to integrate that into a rotation with canola and wheat and do a similar setup. I think the messages they translate, it's just the speed of the rotation is going to be different, because here we need to plant 1 year, graze that year, another year we can do that again, or just plant wheat, barley, or canola or peas in that system. So we can basically translate, but the rotation is gonna be slower just because of the nature of the growing season. Okay. And then sorry, what was the second question again?
And have you only done studies using cattle
Oh,
or other livestock as well?
as well as the principal investigator, let's say like that, only cattle. Um, But I'm from my state in Brazil where sheep and goats production is very huge. We have like 6 million sheep and goats, and we have like 2 million cattle. So sheep and goats, it's very huge. And while I was still like in animal science, all of my colleagues, they would work with sheep and goats, so I would help them as well. So I would do some research with those. But basically, I did most of my work with cattle and most of my work with beef cows. Most of my work beef cows in the system. Some stalkers as well, steers, but beef cattle most of the times. I do wanna point that I'm also working with the Living Labs, the Alberta Agrisystem Living Labs, and we do have a collaborator that he's raising bison, so I'm excited to work with him as well. You are muted. You are muted, Grant.
It's always great to have somebody that's the idea of this communication two-way. And since Eric, we're kind of finished with the questions here, but lots of positive comments, great information, Eric, and thank you from a number of people. I guess like anything, you've got Eric's email, and beyond that, the opportunity for Eric as working and wanting to do research that works for ranchers is something that opens the door to you to follow up with him as well and give feedback. And from that way, so you can build stronger two-way research. And the living labs, as Eric is saying, is one of those opportunities. And one of the people on our call, I know Terry Mappin is in fact part of the Living Labs group. So there's a number of people taking advantage of that. I think Kim Nielsen is as well. But with all of that, that is a great opportunity. And Eric, are you going to be going out to some of the Living Labs sites or field days or presentations so that people will be able to see you there too?
Yes, I usually go. Yeah, I usually visit all the farms at least once a year. The ones that we have the living labs, sometimes more than that. At Terry's place, we go very often there because we have two projects going on. And also for conferences, I try to be present. I know, like for the conference of the Alberta foraging industry, last year it was done the same time that I was teaching, and I guess this year maybe it will be, but I did go like 2 years ago. I was there, so I always try to be in the conference and in the conferences and meet you guys there, which is the best part. So yes, and I'm very open to collaborations, or if you need anything, yes, or questions, yes, anything, you can just reach out to my mail, and yeah.
Okay. Is there anything else prior to us closing here? Any other questions coming in? We're going to be planning another webinar coming up next month, and they will vary dates as we try to meet the opportunities and work with researchers on their very busy schedules, because I know that we were trying to get Eric for another event and probably trying to fit in between teaching and other things. Very busy people and writing papers and trying to manage grad students and everything. Beyond that, also the annual general meeting for the Alberta Forage Industry Group is going to be held in person and online on March 6th, as Amanda's got up on the screen here today. So there'll be an opportunity in March if you wish to get together via Zoom or in person at Olds College. And it's going to be piggybacked with the Invasive Plants Council, who are having some of their meetings there. So an opportunity, Chris Folker from the Alberta Forage Industry Network, one of our directors, sits on the Invasive Plants Council, and that's part of the number of hats that people wear, trying to be immersed in the industry. We have about 12 directors that are involved in many facets of the industry, because this forage industry is very diverse. And with that comes the problem of having talks or people that can be in the right places at the right time. So I want to really thank Eric, and I'm excited to know he's going to be carrying out research and looking into this province and working with ranchers here. So I'm going to thank you, and I guess if there's
another reminder, Grant, I think just mention about our next seminar series speakers who would be, our next seminar series will continue next month on February 11th, because we normally do this on second Tuesday of the month. With just to accommodate Eric, I think we had to decide on a different date because he was not available on that day. So now on, the seminar series would continue on second Monday of every month and starting on February 11th. Just stay tuned for
second Tuesday.
Yeah, second Tuesday of the month. stay tuned for the speaker and their bio.
So hopefully we'll get you to meet another young scientist that's up and coming. And with all the awards that Erick is getting, I know we're in good hands. So, and the students that you're teaching at the university. I remembered my forage course back there. I won't tell you how many years ago that was. But anyway, sure appreciate it. So thank you, Erick.
Thanks again.
Thank you, everybody, for coming. And thank you, Amanda, for as always being wonderful in managing things for us. So I'll say good night to you all. And Erick, now we'll let you off so you can go eat.
Okay, okay. Thank you so much. Thank you for the invitation, and thank you for the attendance, guys. Thank you so much.
Thank you.
Great.
Take
Thank
care.
you.